Hey guys, here's our second application problem for our sinusoidal relationships. In this particular problem, we're riding a bicycle and looking at the distance between your foot and the pavement and how far you have gone on the bike. So it's the height of your foot, which if it's on the pedal, right, you've got a pedal here, its height is going to change, right, as you go around the circle, like that. And so the height as the bike is going is going to follow a sinusoidal relationship. The information we're given is that you're going to start with your foot somewhere. We don't know where exactly. On the pedal, and when the bike has gone 5 meters, so you're going to go 5 meters on the bike, that's when your foot, from wherever it is you started, is going to hit the lowest point. And that lowest point is 11 centimeters above the pavement. I'm going to end up drawing a slightly more detailed picture. And the high point is 45 centimeters. Okay. We've got that, and the bike moves forward on the horizontal distance of that 16.4 meters to complete a revolution. So in a sense, that's our period. So let's get a little bit better picture here. And yeah, it does all the things I want it to do. That's great. Let's see. This is 11 centimeters, if that's the ground. The distance to the top there is 45 centimeters. And with our foot somewhere going this way, that took, let's see, 5 meters of the, so that distance is not the 5 meters. The 5 meters is how far the bike traveled when your foot went from this arbitrary starting point down to the bottom. Now we need to turn this into a graph, and so we've got our, let's try that again. We've got our vertical axis, which is the height in centimeters of your foot off the ground, and then, let's see, we're going to not go underground, so put that there, and this is the distance of the bike, and that's in meters. So starting at some arbitrary point and maxing out, there we go. 11 and 45 are the key values I know about the height of your foot on the pedal. And the first information we were given was 5 meters in distance, and that's when the foot was at the bottom or 11 centimeters above the ground. So that's going back to this information right there. We know that the period, the horizontal distance of the bike moving forward, this thing's going to end 16.4 meters. So let's see, 16.4 is 21.4. It's going to be that distance where your foot, or the distance that the bike has traveled, I should say, when your foot makes it all the way around the pedal again. That being our period. So about exactly halfway there is 8.2. So we'll tack that on. That's 13.2. That must be where my foot is, or your foot is, at the highest point. So let's graph this. And it's not brilliant, but good enough. That's what we're looking for. And let's see, between 45, the high point, and 11, the low point, is going to be our horizontal axis here. Get that all squared away. And let's see, that's 56, 28? It's our horizontal axis. Okay. And let's see. once we've got that, do we have enough to answer these questions here? We've sketched a graph. This point right here should be halfway here, and that should be halfway there as well. And we can sneak that in there. What is that, 9.1 and 17.3. Think if I've got that square. There's your graph. Now we want to write the equation that describes this relationship. I'll probably go with the negative cosine relationship, the one I've effectively drawn. If you wanted to, say, start here and do a positive sine curve, you could do that. And I'll add that one in as well. But let me just start first with the negative cosine graph. And let's see, the period, which we know is 16.4, that equals 2 pi over b. Therefore, b equals 2 pi over 16.4, and if we clean that up, 2 pi over 16.4, I think that's pi over 8.2, 10 pi over 82 is 5 pi over 41. I don't want any decimals in my fraction, so 5 pi over 41 looks good. My amplitude, which is this distance to the bottom and to the top of the pedal from the horizontal axis, looks like it's 17. That's my amplitude. Is 17. I've got B. I've got, let's see, my vertical shift, which we know is 28, the new horizontal axis, and then the horizontal shift, which if I'm doing my negative cosine is going to be 5. So I think I'm ready to write my equation. My height is equal to negative 17 cosine 5 pi over 41 x minus 5 and then plus 28. And that'd be that purple graph that I have there. But I said, maybe you're more comfortable with a positive sine curve. It's the same graph. It would look like that. Many of the parameters are the same. H equals, now we're talking about positive sine. It's going to have the same period. That hasn't changed. My horizontal starting point has changed. All of a sudden, that's x minus 9.1. So when I switched to sine, it became positive, and I'm looking at a new starting point here, and then still the same 28 shift up. So that would be, another way of doing it. Surely you could do a positive cosine graph if you wanted to, starting here and doing that. It's endless how many options you have. But I'm guessing here's something in that neighborhood for the answer to B there. Question C says, find the second time your foot was 43 centimeters above the pavement. So let's see, second time at 43. All right, so looking at the graph, 43, well, let's highlight this. Let's try blue. So 43 is right there. So we may have to check and see, because my graph currently isn't too precise here. Let's see, I have to go backwards. That's 4.1. Then at 0.9, it looks like. That's when I'm going to hit there. Okay, so I don't have to worry about it. My second time hitting that's going to be right there. That's what I'm looking for. So if I had to ballpark it, 14 seconds just based on the scale of my picture here. But even a really crummy picture is going to help you, get your answer and it resonate with the expectation of what you ought to get. So let's go back here. Second time at 43. And we have our equation. I'll stick with the purple one, that h equals negative 17 cosine 5 pi over 41 x minus 5 plus 28. And so I want to find where the height is 43. Again, algebraically, you could give this a shot and punch it into your calculator. Your best option is probably to put this into your y equals, which is the purple graph, and then put y equals 43 into your graph and look to see where they intersect. So a separate, let's do that. So y equals y1, y2 equals 43, and you're going to look to see where they intersect. You're looking for that second intersection there. And let's see, if we do that, we get, let's see, what is that? Find the second time. So this is going to be in a distance that your bike has gone. Which, let's see, I called it x earlier. So when x is equal to 14.48, and I got that from the calculator setting these two guys equal to each other and solving it. And that's it's not time, it's the meters. So when the bike has gone that far, that is when your foot is going to be 43 centimeters high for the second time, given the parameters of this question. All right, so you've got one more to tackle. That's going to be the Ferris wheel problem. So you guys give that one a shot, and we'll talk about them all over together next. Thanks.